pools run into real-world content. This content doesn't come from clean APIs and structured data. You get poor quality scanned PDFs, long emails, Office documents with complex tables, images, audio and video files. This is where agents often break. They can reason, but they cannot really read. So by throwing raw content to your LLMs, agents scramble. With every file that comes in, it writes custom code, uploads images to models, misreads tables, skip figures, and as a result, quality and reliability drops, and your LLM bill goes up. This is exactly where content understanding comes in. Content understanding takes messy multimodal content and turn it into clean, structured, agent-ready output with a single pipeline. Parse, classify, and extract, with built-in grounding, confidence score, and governance. The output is well-formatted Markdown, JSON files with key value pairs that give you agent ready-to-act inputs. Now let's see it in action. So imagine this scenario. 6:47 a.m., alert goes off, there's a signal degradation on Tower Ridge corridor and 42 customers at risk. Today, a non-call engineer needs to search 9 documents, media files, and attachments, and manually investigate and correlate everything. And this is the exact workflow we're going to try to automate. For this demo, we will show content understanding, turning each of the document pulled by the alert incident into structured data, including layout, tables, figures, barcodes, custom fields you define, and classification and routing. We send that information to an agent first via just direct call to a GPT-4.1 for diagnose, identify, and dispatch a plan. And the final act will show all of that can be integrated seamlessly with Microsoft Agent Framework. So first step, we initialize the content understanding client. Very simple, you use the same endpoint as your Azure Foundry resource by initiating with endpoint credentials. And then using the SDK in our Python, you can make a simple pre-built analyzer call with document search. Document search is one of the many pre-built analyzers we have in content understanding. Oh, how do I? Thank you for. All right. I think the extension did not work, but we'll do this together. Okay. So that's the scenario. And this is the flow that we just walked through. And this is how you initiate the client. So we just talked about using the Azure resource endpoint. You can make a simple SDK call to the pre-built document search. So document search is optimized for extracting document layout and embedded elements, including tables, figures, selection marks, barcode, and signatures, and so on. It generates rich information that you can send to downstream applications like RAG or AI search. All right, so we're going to run this code to analyze the site maintenance log. As you can see, it has 2 embedded tables, a lot of information formatted in a way that's not intuitive for LLM and agent to directly extract, selection marks, QR codes, and within a few seconds, you will see the content understanding extracted results. We have 2 tables, output preserved with a row and column structure, 1 barcode, QR code decoded, 2 checked, and 1 unchecked selection marks. And then we further send that information to your LLM to reason and track that as a piece of evidence. For simple comparison, we send the same document to a local PDF parser. While there's not a lot of challenge with OCR because it's a typed PDF file, you will see that it completely loses the table structure, raw bytes, and it also completely misses the QR code and the selection mark information. So as a result, this is a comparison between the 2 outputs. With a local parser, your agent has incomplete information and also have to do a lot of guessing about the structure of the element and what each element means. Content understanding turns that into a LLM readable state and then send to agent to reason through a to-LLM input formatting helper function, which we'll detail in the later section. In the next act, I want to show you some of the prebuilt analyzer that's able to handle multimodal input. And before we dive back into the code, I'm going to get it start running. I want to show you how you can use also low-code, no-code interface for content understanding. Starting with our Foundry portal, when you go to deployments and AI services, you will be able to find content understanding playgrounds at the bottom. So we'll go into content understanding playground. We have a set of pre-built analyzers you can use. For document, for example, for invoice, by running this document, you'll be able to extract critical fields, values, and in the JSON output, you will be able to see also for every text piece and value, the offset and length, also bounding boxes of where it is in the documents you can trace back to a citation. There's a long list of pre-built. Feel free to check out after the session in our documentation. But here I want to show, let's say, we have an audio file that comes from crew members analyzing, inspecting the fiber cut situation. So we'll send that to our audio pre-built analyzer. So this analyzer is able to pull out timestamps and
I am looking to transfer money to my checking account.
And speaker
I have a $1,000 certificate of deposit that matured last month, and I have to use it.
Be sent and summarized to your LLM and agent. So I don't know if you can hear this one well.
Approaching Vault TV3. Visuals on the conduit entry.
It's very quiet.
Yeah,
but basically
I can see the
two crew
crack.
members exchanging information about they're approaching Vault TV3 and then the conduit entry and what describe the situation with a crack and fiber bent.
The protective sleeve is completely off.
Now for other scenarios, you can also click this button to go to our CU Studio. In CU Studio, in the Discover tab, you can see the list of pre-built models you can use across tax, legal, identity, payment, mortgage, etc. Now let's go to video search. We also have a short inspection video file that we want to analyze before we send it to the document analyzers. So here's an example of our
When
video
it comes to the
analyzer.
neural TTS, in order to get a good voice, it's better to have good data.
To achieve that, we build a universal
The data so that this universal model is able to capture the nuance of the audio and generate a more natural voice for the algorithm.
What we liked about cognitive services offerings were that they had a much higher fidelity and they sounded a lot more like an actual human voice.
Okay, finished. Let's see, it's a very short clip.
We've got a fiber strike in this excavation, but before the repair crew can work, we need to address the condition around the line first.
Well, we get a nice summary that can be sent to the LLM for follow analysis. All right, now let's circle back. So basically, I took the transcripts from audio and video, sent it to LLM, also a document file that has 6 embedded images. After we send that to Document Search Analyzer, as you can see, it was able to OCR all the detailed text in the document, preserve its location, as well as text within images. But more importantly, it generates a description about that image across all 6 photos and was able to send to agent to reason. Similarly, you will see that for audio and reasoning. So LLM was able to identify the 3 centimeter displacement, and then also conclude by correlating it between the two, the root cause is around TV Vault 3. All right, so far we've talked about pre-built analyzers. But other scenarios, agents may benefit from decision-ready fields. And other times, you may want to customize a field to extract insight that's specific to your business. So we not only allow you, custom analyzers and content understanding not only allows you to extract, but also reason and infer and generate fields by calculating and reasoning. So let's assume we have 6 different types of input for this scenario of documents, and we want to know exactly, we want to build analyzers for each to extract only the fields that we're interested in. So to do so, you can simply define by identifying your schema, and then for each field, the name, the definition, including the type, method, and a natural language description. Using the SDK, we can deploy all of these custom analyzers. Another very useful type of analyzer is called classifier. Similarly, you can identify categories and what they are for any unknown document that gets sent in. And it has the option of automatically routing any unknown document that comes in to an analyzer, pre-built or custom, to perform the purpose-designed extraction. So here we're going to do that and send the document in. I'm going to have it keep running. So this is the code we said we just walked through for the 6 document types custom analyzers. We deploy that, and it also creates the classifier for the 6 categories and send the document one at a time to this pipeline. So this can take a minute or so to process. We'll circle back after, let's review my pre-processed result first. So this is the kind of result you're going to expect to see. For each type of document, the custom analyzer is able to return your custom defined fields. And note that some of these fields are not found in document. It actually requires reasoning and corroboration for the LLM to do to generate the response. And the agent can additionally collect the evidence and reason for the next action to take. Also for classification, you can see all 6 files are correctly identified and then routed for their respective analyzer. So here's a quick view of the custom extraction results. Now about midpoint, let's recap what we've seen. Content understanding is able to take multimodal content and turn them into text representations that can be further sent for classification and routing to either pre-built or custom analyzers to extract fields and also infer fields and insights that's unique to the scenario. The next 2 acts want to show how an agent can leverage all that information to perform reasoning, to diagnose the root cause, identify material plan within budget, and dispatch what to act next. So in this one, we're going to show a 4-step agent thinking scenario, right? So first, we assemble all the output from what we've shown so far from content understanding. And using the 2 LLM input, it's a formatter from our SDK to the LLM. And then it will diagnose, we're going to send a request to diagnose the root cause, identify the material and build plan, and dispatch an action to the repair crew. So here are the results you should expect to receive. In the root cause analysis, we were able to identify mechanical failure of the shared underground conduit at Vault TV3, caused by a microbend, and a lot of details around that. The evidence chain is attached based on all the document evidence we collected along the way, and a final verdict. For the material plan, right, we have information about the budget cap, that it's approved by a personnel, and was able to build the materials table to move forward with. And finally, in the dispatch email, it was able to identify key personnel from the raw data collection process, and then send all, but only the necessary information for them to act on next. All right, now it leads us to the final act of content understanding, integration with Microsoft Agent Framework. So that entire process can actually be orchestrated using content understanding context provider within Microsoft Agent Framework. The context provider is a primitive in the agent framework that hooks into your agent run loop. it's able to basically see and detect messages before they reach your LLM and act on it. For example, it can detect attachments, process it, and then send the structured output back to the conversation loop. So here's how we can do it with agent framework. First, in the setup, what you need to do is define the context provider with content understanding, endpoint credential, and here we're going to show the analyzer ID, again, with document search. We're also using Agent Framework's Foundry chat client for this scenario. For the agent run, you can construct your agent by providing the instructions, as well as the context provider being content understanding. And you build a message by using this simple prompt and also 9 attachments from the PDFs. We're also going to try ask a follow-up question after we finish the first round of a diagnosis and see how, using Agent Framework, you can use cache results from content understanding context provider and not having to repeat that process. All right, we'll circle back to all the round results as they're going. For this final output, right, you're able to see very similar result that you got by doing the SDK pipeline manually in kind of like one step. And in the follow-up question, the agent was able to answer the question by using the same session and context provider without making new content understanding calls. So quick comparison between what we show in Act 1 through 4, SDK pipeline versus Microsoft Agent Framework. Basically, it's the same underlying service for content understanding, but different integration shape. It does provide, with Microsoft Agent Framework, auto analysis on attachments, automated included formatting code, and multi-turn caching, and also just one provider for any type of agent. So going back, I think our Act 3 result came back. Again, very similar results that we've seen. Act 4, same. We were able to see the diagnosis material dispatch. So a couple of takeaways from the live demo I want to share, right? Start with pre-built document search or other pre-builds when you don't know the particular document type you're analyzing, or you need to send enriched information to LLM and agent to reason through, for example, for RAG and AI search type of scenarios. For other types, custom analyzer may be beneficial for you to pull out specific fields like dispatch urgency, budget verdict, that are actually more reasoned through using content understanding custom analyzers. And then in production, oftentimes you will get payloads or a document that you don't know the type and which analyzer to send to. Use our classification and routing process for production workloads. A single call classifies routes and extracts, and it minimizes the branching logic in your application code. And one thing to call out is that repeated use of 2 LLM input helper function. It's an SDK function that formats content understanding output markdown specifically with YAML front matter, so that it's easy to send structured information to agents to leverage. It also has the option of choosing you send the full document or fields only, and it could result in our scenario, actually 85% token reduction. There are different ways to send your content understanding output to agents. Agent Framework simplifies the process. We also provide direct integration with frameworks like LangChain and Markdown, so you can leverage directly. All right, so going back to our slide, very quick to wrap up. If I can find it. Okay. Maybe I'll minimize that. Okay. All right, so are we presenting? All right, so there's a lot of material. And by the way, all this code, including the demo app and a detailed tutorial notebook, is available in the GitHub for this demo session. And we have a QR code for that if you want to give it a shot. And then please check out our breakout session 242 this afternoon at 4 p.m. to learn more about what's coming in content understanding, including a agentic mode that's able to handle even more complex document scenarios and how it works with toolboxes in Foundry. Thank you all.